Hello everyone, this is me again. Here we are with one of our technicians, Mr. Braden. He is the expert on Prusa, especially the multi-material head. And I will let him take over the video here and tell you how to work with Prusa multi-material, multi-color head. So the class is yours.
All right. Yeah, so this is a Prusa equipped with the multi-material unit. The multi-material unit is this bundle up at the top. And as you can see, there's a tube that runs between the multi-material unit and the printer head. That is so that when you are loading a filament, it can select one of the 5 that are behind and load it to the nozzle.
Okay, here we are gonna go to the head at a smaller distance, right? So this is the multi-material head, as you can see. And here is the place that behind it, if you can see, you can have up to how many spools at the same time?
So it takes 5 at once, but you can do less if you only need a couple of colors.
I see. So you can get up to 5 different spools, whether different colors or different material. And this is the edition from the Prusa company. How much does it cost, Braden?
It's $300 for the kit, and it's only sold as a kit.
Okay, and before we get into details, could you tell us a little bit about, is that a hard thing to add it to your printer?
It's relatively easy to build. They have good instructions. It just snaps onto this rail at the top of the printer, so it's not hard to install. There's a couple of power cables that go over to the power supply. As for operating it, it does require a bit more knowledge in the software, and also the mechanics of the system can be a little bit difficult when loading and unloading hundreds of times potentially for one print.
I see. Okay, so what are you going to show us right now?
So I'm going to point out all the different parts on here, how it loads, and then I'll go ahead and load some filaments so you can see how it does it. So, on top, this is the selector. The selector has a stepper motor that can move it back and forth to align it with one of the 5 holes on the center of the body.
Okay.
And then the filament is pushed by an idler. That's, I believe, this motor right here. And it tries to push all 5 filaments at the same time out through the holes through the selector. But only one is able to go because this motor turns a shaft that applies pressure, a bearing, onto just one of the filaments.
Okay, so I'm showing you all different angles of this multi-material head. Okay, going back to you. So do you want to show us how to load some plastic in it?
Yeah. So on the menu, you just have to select Load Filament.
You see, that's the difference, right? You can
Yes.
say load all or load filament 1, 2, 3, 4, 5. So these options are added to this menu, or they are always there when you buy the original Prusa. Then you say load filament. Do you see all of these options on the Prusa, or when you basically add the multi-material head is when you see load filament 1, 2, 3?
When you do the upgrade, you have to flash the firmware of the original system to a special MMU firmware.
I see. So it is done literally through the update firmware, and that adds all of these options for you to the printer. So here, loading filament 1 is pushed, and now what is it doing?
it's homing the selector. So that's the selector motor needs to know the position in space where the selector head is. And now it's moved it to filament 1, and the light begins to flash to say filament 1 is being extruded.
Okay, and you see now behind the scene, he's pushing the filament through the friction tube for filament 1, and now
That's it.
it is going to pull it in, and
It is loaded, but not to the nozzle. It's only loaded into the multi-material unit. It's being held onto. It's ready, but we're not currently printing anything, so it does not go down the PTFE tube until that time.
I see. And if you want several plastics, of course, you repeat that for load filament 2, 3, 4, 5. You pull them in. All of them will be sucked in into the head, not into the nozzle.
Right.
And then the G code will tell it which one to pull into the nozzle at any point, and basically apply the color at that point. Now, one question, with this multi-material head, can you do a gradient of color, or should the color in each layer be basically the same as the rest of the layer? I mean, in one layer, can you change the color?
So you can change the color within a layer, but you cannot have gradients. There are only sharp edges between two colors.
I see, okay. So, of course, that's the limitation you have when you are using a $300 adapter versus a PolyJet printer that is like $300,000, right? $1,000 more. So you cannot get to have smooth transitions from one color to the other. You get the sharp edges, but at least if your layer heights are not really big enough, right, then that sharp edges can be kind of like kind of jagged edges. So you can have a little bit better transition. At the end of this, we are going to show you some sample printed parts with multicolor. But is there anything else that our viewers need to know about the hardware part of it before we go to the software?
Yeah, so on the printer head, toward the nozzle, the filament detection, the filament runout system is a little bit different. It's called the chimney, and it's basically an adapted version of what comes with the Prusa printer that allows it to detect filaments coming in through the PTFE tube.
So you need that filament detection.
Yes.
With the regular Prusa, you don't have to have it. It's an addition. You can pay for it or not pay for it. But when it comes to multi-material, you need the filament detection. And this filament detection is different for multi-head than a regular one. Okay, please go forward.
Yeah, and then I will just show how inside the multi-material unit, you take off the two tension screws.
All right. You put it at this angle for you.
Yeah.
Here.
You can see inside, here's the white filament that we loaded, and it's occupying just one of the 5 slots. Each one has a Bondtech gear ready to push that respective filament forward through the selector. But only one filament moves at a time because these bearings here are only apply pressure onto one filament at a time, depending on the rotation of this part.
Nice. Nice. Beautiful mechanism, simple yet effective.
Mm-hmm.
And does this guy need as much maintenance as the regular one? I mean, like, do you get as many times the filament being stuck in it as a regular head, or more or less? I mean, like, does it need more maintenance, basically?
So if it's very well tuned, it will rarely need maintenance over a normal printer, but oftentimes tricky filaments or weird shaped models can cause problems, and when it jams, you have to intervene, you have to remove the filament and reinsert it. Fortunately, you don't need to restart the print. It's able to resume where it left off.
That's one of the biggest things. You don't want the multi-material, multi-color print to basically fail and you start it. And one more thing, because this is also called multi-material, not just multi-color. So my question for you is, have you ever seen or done any real multi-material, like printing a PLA and another plastic at the same time?
So
how easy is that?
There are some materials that will be easier than others. Different types of PLA usually share similar temperatures, so those are easy enough. They're different materials, but they're basically the same material. Whereas if you want to print PETG and PLA at the same time, you need to have the nozzle change its temperature drastically between each switch, between each material. And the printer can technically do that, but there will be temperature drift and other oozing problems if the two materials don't have the same melting point.
Exactly. So the most important thing is, if you ever want to print two different plastics, make sure their melting temperature is the same. Make sure they can stick together well. When you cold weld plastic onto another layer of plastic, make sure you stick. So it's really better that you print, let's say, different types of PLA than, let's say, PLA with PETG or TPU or some other plastic that are drastically mechanically different. Okay, amazing. Is there any other hardware thing that we need to know, or we should jump into the software?
I think those are all the hardware differences.
Okay, so now we are going to go over how to work in Prusa Slicer to prepare your part for multi-color printing.
So when you want to print a model with multiple colors, you'll have to consider that when you're designing it. So here's a model of an iPhone, just a rough outline, and you can see that these parts in Fusion are separate bodies. So you can only split the part into different colors where you have separate bodies or separate STL files. And
so first thing first is you bring it to Autodesk Fusion 360. You cannot just right off the bat import it into Prusa Slicer. Yes, please, sorry. Go ahead.
Yeah, and for other modeling software, you may have different requirements. Like in CATIA, they need to be different components before they can be printed in different colors.
And is this software free, Autodesk Fusion 360?
For students, this is free software.
Nice. Is there any alternative to it that is, like, if you are not the student using, you want to do the adjustment that you said you have to do, is there any free software that can do that before you import it into Prusa?
Yeah, so if you have a 3D model that is all one part and you need to break it into separate bodies so that you can print it in multicolor, there are a few options. Blender is free and open source, and you can perform mesh Boolean operations on objects to create separate bodies to split STLs into multiple parts, multiple files, and then print in multicolor that way.
Okay, so again, if you bring an entire one single piece STL file, you cannot do multicolor. You have to break it down into individual components or features, like every extrude, cut extrude, or anything that you want a separate color. You have to break them into individual STLs, right? And either in your CAD software, you can export them separately as STL, or you have to import them into software like Fusion, Autodesk, or Blender to break it down into individual STLs. Okay, please go forward.
So once you've exported your model, you can bring it into the slicer. And so here's a model that's already been brought in and adjusted and prepared for multicolor 3D printing. So each object appears in the pane on the right, and it allows you to select which extruder number you want it to print out of. So here I've color-coded them. Extruder 2 is green, extruder 3 is gray, 4 is orange, and 1 is the blue that you're seeing on most of the model. And it gives you a really good preview of that. It even shows you how big the purge tower will be. And if we view the sliced view, you can view internal to the model, how it prints each layer, how even in one layer you have multiple colors, but that it switches between those colors using the purge tower.
And could you explain briefly what is the purpose of the purge tower?
So when you go from one color to another, there may be some leftover liquefied plastic residue in the nozzle from the previous color. And if you're going from black to white, you don't want to smear any of the black color into the part that's now being printed in white. So you need to purge the nozzle. That's just get rid of some of the material there by just printing a little block off to the side out of that color. And generally printing 30 cubic millimeters or so is enough to completely reset the nozzle and prepare for the new color.
Thank you. So the whole purpose, as he very correctly mentioned, is everything is coming out of one nozzle. And before you switch to the next color, you want to make sure that your nozzle is clean from the previous plastic. Okay, and so you just select which feature, which color here, right? Which spool basically, and then you slice it and it's ready to go, right? Could you go back to the Fusion and just briefly tell them exactly how you broke it down into components? Like you brought it all as a single STL file, right?
So this was designed in Fusion and designed into multiple parts as I went.
I see. I see.
However, if you are going to use Fusion to split parts, there is a split body tool. You simply select the body, and then you will need a splitting tool. It's usually a plane or surface. And you select that tool, and it will cut through the object along that plane. And now what I've done is just cut the main part of the body into two. So let me hide one of them, and you can see I just trimmed off the back edge of the case there.
I see.
And then you would export this all as one file. Fusion also supports 3MF files, so it will keep all of the positions of the objects correct relative to each other. And so it really is just drag and drop into the slicer and pick what colors you want for each part. You can just click on them and select the color in the side.
So if you want to, let's say, bring apart a STL from, let's say, SolidWorks, what format do you suggest that you export from SolidWorks to bring into Fusion and break it into parts? Is it STL? Is it 3MF or any other format? What's the best format before breaking it into individual components? Is STL good enough, or other formats are better than STL?
So other formats, if you can, while you're designing the object in your original step file, you should strive to plan for multi-material use if you're going to print out of multiple colors.
That's right.
But the best option bringing into Fusion is a step file, because it retains geometry without resorting to just converting to a mesh, which is lossy.
Exactly. So do not basically export it into a single STL if you could not use multi-body. In SolidWorks, we have the multi-body, and that is probably one of my future lectures. I'll show you how to use SolidWorks multi-body, and then you can basically export your total geometry into several STLs. Each one is within its correct position and orientation, but when you bring it into your slicer software, it is already separate STL files. So if I can do that in a software like SolidWorks, I can manage to basically have STL files, but individual STL files for each one of those colored features. I do not need an intermediate software like Blender or Autodesk, right?
Yes.
Because ultimately what you exported from Fusion was STL. Is that correct? So you could import it into a slicer, Prusa slicer. So if you can do it just with the help of SolidWorks, as I said, that is going to be one of my future videos. I'll show you how to do multi-body design with multi-STL files. But if you cannot and just make it one single giant file, do not make it STL. Make it a step file so that when you import it into Fusion or Blender, the software can basically break it into individual components. And there is one item on the Prusa slicer, right, breaking it into objects that O and P on the top, next to the plus and minus. Do you think those can do any job for you too? So have you ever done that, breaking it into, because I have done it in one of my previous videos, I have done it on an assembly, right? So it was an assembly, right. I saved the whole assembly as a single STL, but when I used that O that you can see right here, that O, it could break it into individual components. But when it did, it took them apart. It did not keep them in position for me.
Right. So
you see, so you're gonna lose the position. That's the hard problem.
I'm gonna import the combined STL, the multi-part object, and Slicer will actually warn me that it contains objects positioned at multiple heights. So it asks you if you want to consider it as a single object having multiple parts, and that is what you want to do if you are printing multicolor. However, if I just said no, like you mentioned, now that part has appeared. I'll drag it into view. But when I go to arrange the tray, boom, it exploded. And all the different geometries are scattered around the tray, and it will not print properly.
Yes. So it's not really for a single part. It was for an assembly, and if you just cared about the portion of an assembly to be printed, but you exported the entire assembly as a single STL, and you don't care about the position of the parts, then yes, that breaking into objects that I showed you in my previous video is useful. But if it's a single part and it's not saved as a multi-body part, then definitely you need to go through the intermediate software like Autodesk Fusion or Blender. Okay, is there anything else, Braden, that you want to share with us about how to use this software, hardware, or anything about the multi-head?
Yeah, so there's one advanced feature. You can add a modifier to a part in Slicer. And if you are printing with the multi-material unit, you can adjust the properties to change that modifier's extruder. So you can select the type of extruder that an object will use within certain bounds. So here I'm just going to change these all to 4 so that we can just get a different color. And when I slice that, now you can see where that box was placed, where it intersected this part here. It's printing blue outside the box and orange inside the box because orange was extruder 4.
I see. Okay, so within a single component that you exported from, let's say, Autodesk, you can use the modifier that I mentioned in one of my previous videos. And back there, when it was a single extruder, all I used the modifier for was to change the local infill percentage or number of layers or something. But now that you have the multi-head, you can also select using which spool to print that area of the overlap with the modifier. So you can have basically a region within a bigger region with a different color. And you can basically manually add a new region with a different color as long as you know what size is that modifier and where to position it. You can basically add further color to your part and make it more complicated. That's a very brilliant feature.
Yeah, it's a simple alternative if you don't have any of the other software available to split up a part, or you just need to simply divide something into 2 colors down the middle. A modifier might be the way to go because it's fast and it's in the slicer already.
Okay, just accurate size and accurate position. Exactly overlaps the area that you want a different color, and each modifier has those features. You can resize them, you can reposition them, and there is more than one modifier. You don't have just a box, you have basically cylinder and other shapes. So you can basically, as long as that area is a simple area, and you can make it using a combination of primitive shapes like cube, cylinder, and so on, this is like your last option and the simplest option without any further advanced thing. But as I promised you, in my next video, I am going to show you how to do a multi-body in SolidWorks so we can skip those intermediate steps in Autodesk Fusion and or Blender, and then using a better quality of video, because I know this video is not like perfect, it's a little bit blurry. I'm going to hopefully show you how to break it down into Fusion for separate colors. Okay, thank you so much, Braden. We totally appreciate all of the amazing info that you had for us.
Yep.
Because although I have a printer myself for Prusa, I have never worked really with multi-head, and that's where our expert technicians come in to show you this information. Is there anything else, or we can just say goodbye?
I think that's it.
Okay. So thank you so much. Here is Braden and me in PRAU Prescott RP Lab, and we'll see you in the next video. Thank you so much.